Here's our two functions. Boom, boom. Very similar. And okay. If I asked you to sketch this, let's just rewrite them down here on the grids. So off to the side here. All right. The other pen. Y is equal to x squared minus 4x plus 2 over x minus 3. And this one, we get y is equal to x squared minus 4x plus 3 over x minus 3. Okay. Let's do the first one. What's the vertical asymptote here? 3. So at 3, we mark a vertical asymptote. Now, if you punched it into does it have a horizontal asymptote? No, it does not, because the degree of the top is bigger. So there's no horizontal asymptote. We're not covering that in this class, so we don't have to worry what that's going to look like. But this graph will look like this. And it's not really that important that you understand why. Okay, that's what the graph looks like. It actually has what's called a slant asymptote, which is this dotted line here. That's irrelevant to this. This is what the graph looks like. If I change this +2 to a +3, the graph will look like this. It's a straight line with an open circle. Open circle means that is a point of discontinuity. It does not exist. Where does that point exist in terms of x values? What's its x coordinate? Oh, I drew it. Wow, look at me. There, that's better. It's at 3, okay, which makes sense because you have a 3 in the denominator. But why is this a straight line, essentially? And that's all curved with weird asymptotes and all that. Well, if you have a quadratic, what should you do? Factor it. Okay. So what multiplies to 3 and adds to 4? That's a -4. -3, -1. What happens to those -3s? They cancel each other out. You're left with -1, or x minus 1, which is what type of line? A linear line, okay? We have a linear line, a y-intercept of -1, a slope of 1, so up 1 over 1. But because we had this x minus 3 that cancels, we have a hole in the graph, a POD, point of discontinuity. Okay? Even though the x minus 3 cancels, it still creates a hole because it is an undefined point. If you plug 3 into this original equation, everything blows up. All right. Are we okay? Okay, so when you factor everything and one of the factors cancels, it is not a vertical asymptote, it is a hole, a POD, a point of discontinuity. Okay, a pod, if you will. All right, so let's look at, let's quickly do this graph here. X squared plus 3x plus 2. What do? Factor it. So you get x plus 2, x plus 1 over x plus 1. X plus 1's cancel. And you're left with x plus 2. Okay. Something canceled, so we know we have a hole. So POD at x is equal to what? -1. How do you get the y value? We know the x value of the hole. How do we get the y value? Any guesses? No, it's when x is -1, we have a hole. Plug it into what's left over, into this leftover function, all right? So the y value at that point will be -1 plus 2, which is 1. So the coordinates of the POD are -1 and 1. So you can mark that on your graph. -1 and 1. We have an open circle, a hole. This is a linear line with what y-intercept? 2. And a slope of? What number's in front of the x? 1, right? So it's up 1 over 1. So from that point, you go up 1 over 1. There's your second point. Draw your line. Can't go through that point, so you just leave it as an open circle. And there's the equation of the line. Okay? With an open circle. Okay? Okay. So this is just saying point of discontinuity is when you have a factor that cancels. Canceling the common factors. Okay? All right. X cubed minus 7x plus 6 divided by x minus 1. Right? Yeah, x minus 1. Now, normally I would have you factor the cubic because we know how to do that now, but I'm just going to give you the factor form right now. Okay? So that factors to x plus 3, x minus 2, x minus 1. Okay, there's the factored form at the top. What cancels? X minus 1s. So now I'm left with y is equal to x plus 3, x minus 2. Where's my POD? X is equal to 1. How do I get the y value? Plug it into what's left over. So if I put 1 into here, so 1 plus 3 is 4. 1 minus 2 is -1. So I get -4. So the coordinates of your POD are 1 and -4. I've got my POD. What type of graph is that? That is a parabola. Okay. Now it's math 11. So it's a parabola that has, okay, degree is 2, or parabola. I'll tie it into what we did yesterday. Leading coefficient, positive or negative? Positive. Right. So if you have a degree of 2, even, leading coefficient is positive, both arms are up. Right. Do we know any other information? What's a 0? What's another word for it? X-intercepts. What are they for this parabola? Okay, -3, +2. So you mark -3, you mark +2. Let's do the y-intercept. That is when x is equal to 0. What's my y-intercept? -6, because if I put it in there, 0, I get 3 times -2. So my y-intercept is 0, -6. All right, so I'm going to mark that. I don't know, there. Who cares? We should also mark the POD. Where is it? 1, -4. So 1, -4. I don't know. It's right there. Can you draw the graph? Draw it, please. Parabola opens up. There you go. Is that okay? All right, we're doing one more. Oh, this dog show. Okay. What do you need to do? When you get something that looks like this, what should you do? Factor it. Now, it is a cubic up top, so normally you would have to be like, what are all the factors of 15 divided by what are all the factors of 2? And then you write them all out, and you test them, and you know one's a factor if remainder is 0, and then you would synthetically divide it, and write it all out, and that would be the top factor. And then you got to factor the bottom. So you want to write the whole thing in factor form, but through the magic of Math 12 COVID version, we're going to get this. X 5 minus 3 plus 1 divided by x plus 1. Oh, go away. 1, 2x. All right, there it is factored. Good job, peoples. All right, so once it's factored, what do? You cancel everything that can cancel. By x minus 3. Okay, 2 factors canceled, which means what? There's 2 holes in this graph. Okay, so PODs. We have one at x is equal to -1, and we have one at what? What's the other factor that canceled? 2x plus 5, so it's at -5/2, or -2.5 if you prefer. How do you find the y values? Plug it into this, right? What's left over? So if I put -1 in there, I get -4. So we have 1 at -1 and -4. The other one, put -5 halves in. For the people that like fractions, you can calm the denominator. You get -11 halves. Or -5.5 for the non-fraction people. So we have a POD at -5 halves and -11/2. If you're doing it in decimals, it's -2.5 and -5.5. All right, so we've got our 2 PODs. So we're going to sketch it now. Are we ready to sketch it? What type of line are we going to actually draw here? A linear, because it's just x minus 3. Has a y-intercept of -3. 3. Our PODs are at -1. Oh. Let's go -1 and -4, so somewhere here. The other one is at negative, let me mark that, -1, -4. The other one's at -2.5 and -5.5. Line them up so they work. There we go. Draw a line. I'll give you actual graph paper on the test to do this, so you're not just guesstimating. That's the graph. Just got 2 holes in it. You can have graphs that have like multiple asymptotes and multiple holes. You can do a whole bunch of different stuff. Are there any questions? Anything? All right, I would like you to sketch 1 to 5. You're just sketching, okay? Just like we've done here.